Hello there, this is Dr. Ken and Bear here, my teaching assistant. Say hi to the good people, Bear.
Hiya.
With a lecture for my ancient Greece class today, which I'm calling Measure and Mysticism, which is about Pythagorean philosophy. And this is a complicated topic, not the least of which because of the nature of the sources. Pythagoreanism is interesting in and of itself as a philosophy, as an important influencer of people like Plato and Aristotle, and for the scientific accomplishments that have been bequeathed to us from the Pythagorean tradition. But as you shall see when I go over this subject, it presents an interesting problem for the historian as well, owing to the nature of the sources. So we unfortunately don't have anything produced by Pythagoras himself, though we know that he did write. We're told that he wrote things. What we mostly have is a work by a later biographer named Diogenes Laertius, a Greek writing in the Roman era, who had access to a range of sources that we don't. But that too is problematic because the sources that he has, or that he had access to, tend to be contradictory, and he didn't necessarily select critically amongst these sources for his information. So I'll be coming back, and so if you get an inconsistent picture of the Pythagoreans from me today, this is in no small part the reason. The first slide that you'll be seeing here is a currency conversion. I thought since we're dealing with measure and amongst other things that currency would be interesting to explain, just to show you how it works. So you'll hear references to talents and minae and drachmas and things like that. and just very basically, one Athenian talent, and the units varied from city-state to city-state. One Athenian talent was 36,000 grams of silver, and that equals 60 minae, or 6,000 drachmas. So these are units of currency, but they're also units of weight. And so you can have a talent of silver or a talent of gold, or conceivably something else as well. So that currency conversion is there for your attention. Moving on to our main topic of Pythagoreanism. So this is, of course, a philosophy founded by the ancient Greek philosopher Pythagoras. His dates are about 570 to 480, 490 or so BC, pardon me, which seems to have prescribed a very highly structured way of life and espoused the doctrines of metempsychosis, which is reincarnation, transmigration of the soul after death into a new body, human or animal or sometimes vegetable. Pythagoras is said to have traveled to Egypt and Babylon, where he studied their mathematics, astronomy, and mysticism. The biography of Pythagoras itself is again a subject of some concern for the historian because of the many contradictory things that we're told about him. Where did he come from? We know that he traveled to a number of places. We know that he was connected with the Greek city-states in Italy, but some of his ideas appear to derive out of more Eastern traditions, probably coming from Persia or through Persia, originating perhaps even farther east, maybe even some of them coming from China. As we'll see when we look at Diogenes Laertius' biography, that there are many interesting facts about him, we can't take all of which to be wholly accurate. We're told he was married to a woman named Theano and had at least one daughter named Damo, and two sons, Teleuges and Menesarchus. Sometime around 510 BC, presumably to escape persecution, and this is a recurring theme with the Pythagoreans, he fled to Crotona on the peninsula of Italy, a land used as a source of slaves for the Greek world around that time. There he established a communal society that was to become a prototype for a number of others in the future, like the Judaic Essene and Therapeutai communities some 3 to 5 centuries later. Those who became his students, and there were two types, the mathematikoi and the akousmatikoi, the hearers and the knowers. Um, they lived together in the same sort of communal compound, though perhaps not in the same house, just a kind of communal village or I say compound-like affair. Um, they lived a communal life together with common rules, common meals, and common possessions. There's a saying amongst the Pythagoreans, friends have all things in common. It would be often quoted by Plato. It even winds up in the Bible. Um, and there are a number of aspects of Pythagoreanism that seem to have influenced Christianity as well. From this group would come the disciples who would spread Pythagoreanism all over the ancient Greek world and later the Roman world. Pythagoras himself appears to have been very different from other Greek sages. These are the literate and educated men of his era, in that he refused to admit that he knew anything, and can thereby not bear the title of wise man or sage. He therefore invented the word philosopher, we're told, which means lover of wisdom. Now, a number of these things apply to Socrates as well, and Socrates claimed to know nothing, and thus people considered him wise. So there are some interesting similarities, and certainly when we come to Plato, we've already seen some of Plato. He's very much influenced by the Pythagoreans, and the impression that he gives us of Socrates may well be through the lens of Pythagoreanism. Plato probably was a Pythagorean. That's controversial, but I tend to think so. Pythagoras seems to have brought many customs and beliefs from his sojourns into Egypt and Babylon and shocked the Greek world with some of his doctrines. He wore trousers like the Persians, we're told, and when the Greeks were not wearing trousers being a sign of barbarian style. He wore his hair long, a practice that would become a habit of his subsequent disciples and would be a mark of the Pythagorean. The Pythagoreans, as vegetarians, with somewhat liberal thinking individuals with long hair, were often viewed by their critics as the hippies of the ancient world. That's a modern, obviously, perception, but it's perhaps apt in some ways. In the descriptions of him that we get, he's said to have had a birthmark, Pythagoras, on his thigh, but otherwise very little is known about his physical appearance. We have a later source, Iamblichus, in his biography of him. He says, as soon as Pythagoras came into Italy and Sicily, which cities he understood which cities he understood had oppressed each other with slavery, he inspired the inhabitants with a love of liberty, and through the means of his auditors, the akousmatikoi, the lower level of initiates in a society, restored to independence and liberated Crotona, Sybaris, Catanes, and some other cities. So this would imply that one of the first things that Pythagoras did upon his arrival in Italy was to abolish slavery. So this seems to be, if this is true, it's an interesting subject, because nobody else really, apart from Plato, who sort of dabbles a little bit with the notion that maybe slavery is not a good thing, but really only a very light touch. This is highly unusual if it's true. Now, the problem with someone like Iamblichus or Porphyry or some of the other sources, Plotinus, that we get, for example, on Pythagoras, is they're all sort of latter-day Pythagoreans. They're called Neo-Pythagoreans or Neo-Platonist, mostly from the 1st or 2nd century AD, and they have their own agendas and they are products of their own eras. But so this is, I'm telling you what they've said. How much of it is accurate, I don't know. We're told that Pythagoras taught his disciples to avoid oaths, that their language should be such as to render them worthy of belief without oaths, which interestingly would be a trait of the Lollards some nearly 2,000 years later, the first Reformation in Christianity. He counseled against seeking revenge, and by doing so preceded Jesus' admonition to return good for evil by 500 years. He advised women not to wear expensive apparel and condemned animal sacrifices. He ordered his disciples to abstain from all animal foods and from wine, and to have an unstudied contempt of and hostility to glory, wealth, and such like. Pythagoras and his disciples dressed in pure white garments, we're told, and he did not use those that were made of wool. He also influenced his followers to avoid public baths as well. So these are amongst the kind of details that we get, and there are a few more as well that we'll see when we look at Diogenes Laertius. I'm just going through them, but we'll think about now where some of his ideas seem to have come from. He went to Egypt and Babylon. He brought back a lot of knowledge on medicine, we're told, and healing herbs. Thereby began a practice of medicine amongst the Pythagorean communities. As I mentioned earlier, among his other accomplishments, he also could be considered a doctor. Likewise, since he was an accomplished player of the kithara, a musical instrument, he could be classed as a musician as well. The skill of the medicinal arts was continued by his disciples among the Judaic Pythagoreans, and it's recorded by Philo of Alexandria that their musical abilities were continued in hymn compositions and the development of choirs for their worship services, especially among the therapeutai in Egypt. So these are latter-day Pythagorean communities. Pythagorean thought was dominated by mathematics. All is number was a saying of theirs. But it's also profoundly mystical, and this is sort of one of the fundamental contradictions of Pythagorean philosophy, that it seems to be a science on the one hand and a mystical cult on the other. In the area of cosmology, there's less agreement about what the Pythagoreans believed, or what Pythagoras himself actually taught. But most scholars believe that the Pythagorean idea of the transmigration of the soul is too central to have been added later, and that must have come from Pythagoras. The Pythagoras conception of substance, on the other hand, is of unknown origin, partly because of various accounts of his teachings are conflicting. The Pythagorean account actually begins with Anaximander's teaching that the ultimate substance of things is the boundless, or what Anaximander called the apeiron, we'll recall from last time. The Pythagorean account holds that it is only through the notion of limit that the boundless takes form. So the Pythagoreans are interested in the ideas of limit, but also the unlimited too. This features prominently into a number of the writings about them. We have nothing that survived from Pythagoras himself, and rely on the writings of others like Parmenides, whom we saw before, Empedocles, Philolaus, and Plato. People either considered to be Pythagoreans or whose works were thought deeply indebted to Pythagoreanism. This results in a very diverse picture, in which it is difficult to ascertain what the common unifying Pythagorean themes were. If we rely on Philolaus, whom most scholars agree is highly representative of the Pythagorean school, one has a very intricate picture. Aristotle explains how the Pythagoreans, by which he meant the circle around Philolaus, developed Anaximander's ideas about the apeiron, the unlimited, and the peiron, the limit, as well. So we get those Pythagorean mathematics from Aristotle. So we know that Babylonian mathematics figured prominently into Pythagorean beliefs and ideas, and Pythagoras is said to have traveled there. What do we know about Pythagorean mathematics? Well, I put a fair amount in the notes, but they were pretty advanced actually, and would have had to be to construct some of the things that they did. So amongst other things, they appear to, well, there's a Babylonian tablet, for example, that gives an approximation of the square root of 2, accurate to 5 decimal places. There are clay tablets that date from 1800 to 1600 BC that cover topics which include fractions, algebra, quadratic, and cubic equations, and an earlier version of the Pythagorean theorem. And the Pythagorean theorem does seem to have, though we attribute it to Pythagoras, it seems to have derived out of both Babylonian and Egyptian mathematics. The Babylonians may have known the general rules for measuring areas and volumes. Recall how some of the philosophers that we looked at previously were interested in these sorts of subjects. and again, some of it filters through Pythagoreanism. The measure in circumference of a circle as 3 times the diameter and the area as 1/12 the square of the circumference, which would be correct if pi is estimated at 3, are products of Babylonian mathematics. The volumes of cylinders as the product of the base and height, however, derive again from that. The Pythagorean theorem was also known to the Babylonians. There was a recent discovery in which a tablet used pi as 3 1/3. And you can see, actually, I think, yes, in some of the examples that I'm showing, what appears to be Pythagorean theorem. So they also used Fourier analysis to compute ephemeris. These are tables of astronomical positions that was discovered in the 1950s. So complex astronomy for measuring the rising and settings of stars, for various reasons, and planets. All that is in Babylonian mathematics, and Pythagoras appears to have adopted it. So most of this knowledge actually came to the Greek world a bit later. Some of it came through the Pythagoreans, but a lot of it came after the conquest of Alexander the Great of Babylon, and it's transferred to the Greek world from there. The other source of Pythagorean mathematics is Egyptian mathematics, and I put again quite a lot in the notes that I'm not going to go over here. Their system worked pretty well, except that they seem to have attributed more mystical qualities to number, which again is in keeping with what we think we know of the mathematics of the Pythagoreans. And I'm not going to go over all that, but they worked with fractions as well. The symbol for fractions was an oval written over the denominator. Nothing was written in the numerator's position because all the fractions in the Egyptian system were used 1, so 1/2, 1/4, 1/3, whatever. So simplistic forms of fractions, but they could actually represent other fractions by a combination of these. So 7/8, for example, would be written as 1/2 plus 1/4 plus 1/8. So bizarre way of doing things, but this is how they did it. We're told that Pythagoras went to Egypt and studied their lore of the priest at Memphis and Diospolis. And there he studied the rope stretchers, and you can see an illustration of what the rope stretchers did, which again is a form of Pythagorean theorem. And by the way, I should have said earlier, for those of you who aren't necessarily mathematically inclined, Pythagorean theorem is the statement that the square on the hypotenuse of a right triangle, that's the long side of a right triangle, is equal to the sum of the squares on the other two sides. We represent it with the equation c squared equals a squared plus b squared. It can also be represented geometrically by extruding a square from each side of a right triangle. And one way to actually find this measurement is to extrude those squares and fill them with objects of roughly the same size. So if the squares on the other two sides of a right triangle, if you fill them with pebbles of the same size, added together, that same number of pebbles will fill the square extruded from the hypotenuse, the long side. But Pythagorean theorem, as we call it, is so essential to building anything that has right angles in it. So virtually every structure that you can conceive of built since antiquity has used Pythagorean theorem in some form or another, and we use it to this day. It's that fundamental. As I mentioned, the Egyptians have mystical elements associated with the numbers as well, and this appears to have been a feature of Pythagoreanism. But was it the original, or was it something added later, or was it a kind of smoke screen to conceal the science that they were doing? We don't know. I can only give you what the sources have told us. So what we call today Pythagorean number mysticism corresponds to the underlying philosophy that explains in part the essence of Egyptian science and art, that is, again, attributing these characteristics to number. The philosophy of number is based on the functional character of number, in part, but also the symbolism. So with regard to this esoteric or hidden feature of number, we you need to avoid the mistake that 2 is not simply 1 plus 1. It is itself a kind of phenomenon, a kind of consciousness of multiplication. Um, it's the notion that of the plus in relation to the minus. It's a new nature. The number 2 it has its own peculiar qualities, and the next slide, and this is true of any number, but the next slide will go through these. So these are the terms that seem to be used to refer to these numbers in their mystical, symbolic significance. I'll briefly go over them. The monad is 1. That's the absolute state, the first number. And remember that philosophies derived from Pythagoreanism maintain, as Parmenides did, that there is an ultimate unity of all things, that all are ultimately one. So the number 1 has a major significance associated with it. 2 is the dyad. It's also the first feminine number. Numbers have gender in Pythagorean mathematics. Odd numbers are masculine, and even numbers are feminine. I'm not going to go through them all, except to mention perhaps the number 10, the decad. That's sometimes referred to as the all-complete number, and sometimes called the tetractus. And tetractus it's a weird word. It means literally something like the number 4, but it's used to refer to the number 10. So I put a lot in the notes about this, what I could find, and again, how much of it is part of the original mathematics of Pythagoreanism, how much of it was invented later, we don't know. But the next image you see shows you what's called the tetractus of the decad. And remember, decad's number 10. Tetractus by itself simply means the number 4. But it's referring to the number 10, so this is a bit strange. The tetractus symbolized the 4 elements, earth, air, fire, and water, which we saw with Empedocles and later Aristotle. The first 4 numbers also symbolize the harmony of the spheres in the cosmos. And notice on the diagram the triangular shape that's depicted there. It consists of 1, 2, 3, and 4 dots arranged in a triangle. Add them together and you get 10. So it's counting 1, 2, 3, 4, but when represented in this way, it gives us the number 10. This seems to be why it's called the tetractus of the decad. These first 4 numbers, 1, 2, 3, 4, symbolize harmony, the harmony of the spheres and the cosmos, another feature of Pythagoreanism I'll come back to in a bit. And the 4 rows add up to 10, as I say. So this tetractus can also be seen to represent the organization of space. The first row, 0 dimensions, a point. Second row, 2 dimensions, a line. The third row, 3 dimensions, a plane defined by a triangle of 3 points. The fourth row represents 3 dimensions, a tetrahedron defined by 4 points. So, is it symbolic? Is it, or is it just purely mathematical? It seems to be a little bit of both. There's even a prayer associated with the tetractus. I won't read. Well, I'll read it out. The source is somewhat. It comes from the Neo-Pythagoreans, but according to this, it says, "Bless us, divine number, thou who generated gods and men, O holy, holy tetractus, for the divine number, thou that containest the root and the source of the eternally flowing creation. For the divine number begins with a profound, pure unity until it comes to the holy 4. Then it begets the mother of all, the all-comprising, all-bounding, the firstborn, the never-swerving, the never-tiring holy 10, the key-holder of all." And that's very cryptic at best, but that's a prayer that seems to have invoked the tetractus. There are other. Well, we're told there's a Pythagorean oath that mentions the tetractus, and it's very strange if that's true, because we're told the Pythagoreans didn't make oaths. But the oath supposedly goes, "By that pure, holy, 4-lettered name on high, nature's eternal fountain and supply, the parent of all souls that living be, by him with faith find oath I swear to thee." and that's probably a later invention of a revival of Pythagoreanism in the Renaissance, considering that it rhymes in English. That suggests that it's not original. Again, I put more on the tetractus. There is a quote attributed to Pythagoras himself, although again, I'm skeptical as to whether it is or not, saying that tetractus, also known as the decad, is an equilateral triangle formed from the sequence of the first 10 numbers aligned in 4 rows. It is both a mathematical idea and a metaphysical symbol that embraces within itself, in seed-like form, the principles of the natural world, the harmony of the cosmos, the ascent to the divine, and the mysteries of the divine realm. So revered was the ancient symbol that it inspired ancient philosophers to swear by the name of the one who brought his gift to humanity, Pythagoras. So, sorry, this doesn't come from Pythagoras. This is a later Pythagorean making this argument. But saying again something about swearing oaths to Pythagoras, which seems to contradict what we were told about Pythagoreans swearing oaths. Anyway, the tetractus, the decad, is sometimes represented in the form of tetragrammaton, which means the 4-letter word, as well. So there's a lot of mystical symbolism, stuff associated with magic. Does it come from Pythagoras? I don't know. So I'll talk a little bit about at least an idea of a later Pythagorean named Philolaus. His dates are 470 to 325. And he's the one that sort of puts forward this notion about what's called the central fire and counter earth. So the whole basis for this theory, and the idea is that there's another earth to counterbalance this one. The Pythagoreans seem to believe that there had to be 10, or at least Philolaus and his followers believe there had to be 10 bodies among the heavens, in the presence of only 9 visible ones, and these are the planets, the moon, and the sun that could be seen from Earth without a telescope, led to the belief that as 10 was the perfect number, and the basis for much of their theories, there necessarily had to be a 10th planet, heavenly body, which was therefore hidden. So in astronomy, Pythagoras taught the Earth was a sphere at the center of the universe. We're told, he recognized that the orbit of the moon was inclined to the equator of the Earth, and was one of the first to realize that Venus was the evening star, as well as the same as the morning star. The Greeks called the planets, they give them the name, it means wanderers, because they move differently from the other stars. They didn't know why they were different necessarily, but they understood the planets were different from the stars, but still classed them as stars of some type. Pythagoras taught the movements of the planets traveling through the universe created sounds that could be perceived by those who were trained to hear them. The music of the spheres could be replicated using a single-stringed instrument called a monochord. Pythagoras used the monochord to explain musical intervals and harmonics to his students. He taught how harmony may be produced when tuning the high and low notes in the octave, thereby laying the foundation for many of the theories and teachings that have come down to us through the musical traditions. He effectively discovered the octave and did it mathematically. By 500 BC, most contemporary philosophers considered the Earth to be spherical. This was obvious evidence from the behaviors of objects near the horizon. This meant that all objects on the surface of the Earth had to be attracted to its center in some way, otherwise they would fall off. It also required that these objects, such as stars and planets, to float above the Earth in relation to its center, otherwise they would presumably move away rapidly. The argument, reasonable in view of the data available at the time, resulted in a geocentric worldview, with everything in relation to the Earth. When the movements of the celestial bodies convinced Philolaus that the world must not only be turning on its own axis, but revolving around a fixed point elsewhere in space, he was faced with the problem of explaining how a spherical world could move in this way without spilling everything on the surface into space. He came to the conclusion that the direction of up and down don't really exist in space, except that all things must fall towards the center of the universe, around which all things, including the Earth and Sun and all the planets, must therefore revolve. As such, the Earth would be a flat world, and the underside of the Earth face this fiery central point at all times. Otherwise, everything on the planet would fall off. So, in Philolaus's view, it seems there was not only the sun, but there was another thing, the central fire, which we can't see. But this created a contradiction within the Pythagorean school. Since planets, in their understanding, were composed of a fiery or ethereal matter having little or no density, they could quite easily rotate eccentric to the Earth without becoming off balance. However, the Earth was obviously made of the denser elements of earth and water. If there was a single Earth revolving at some distance from the center of space, the universe's center of balance would not coincide with its spatial center. Since this was the point towards which things fell, the Earth would must have a counterbalance of the same mass, or the universe would be flung apart. The problem led Philolaus to develop the idea of a counter-Earth, a second, also flat Earth, and identical but opposite to ours in every way. The counter-Earth is referred to as the antichathon. It's likely that Philolaus believed the whole orbit of Earth was composed of an ethereal sphere, with the Earth and counter-Earth being local, dense points on its surface. Again, approaching something like the truth. The theory was very creditable attempt to incorporate all known cosmological data at the time, and indicates the sophistication of classical Greek thinking. The ideas of a flat Earth, counter-Earth, and central fire were all eventually superseded by the theory of gravitation, which is currently held, of course, by the scientific community. The counter-Earth is still a popular motif, though, in science fiction and fantasy writing today, usually serving as an allegory for the real Earth. So even today, some science fiction writers imagine that on the other side of the sun, there's another Earth like ours that we simply can't see because the sun's always between us. And that comes from this notion. However, there's an interesting kind of afterlife to this notion of the counter-Earth in the ancient world. So in the 1st century AD, after the idea of a spherical Earth superseded the original counter-Earth theory, a Latin cosmographer named Pomponius Mela developed an updated version of the idea, wherein a spherical Earth must have a more or less balanced distribution of land and water. Mela drew the first map on which the mysterious continent of Earth appeared in the unknown half of Earth, or a mysterious continent appeared. He called it the Antichathon. We'd call it the Antipodes. This continent, as I say, describes by the name of Antichathon, which you can see in the map that I'm putting up here. I include the Pythagorean table of opposites. Now, this comes from Aristotle's Metaphysics, and he refers to, after discussing Philolaus and the sort of things that I've just told you from Philolaus, Aristotle says, or talks about others of the same group, and gives this table of opposites. So does this figure into what Pythagoras actually taught? I don't know. Maybe. It seems to correspond roughly with the number theory. So notice that good and evil are there, odd and even, male and female. Whatever the Pythagoreans may have originally intended with this, it seems to have been adopted by later philosophers to sort of justify a kind of misogyny against women, because notice women are in the column associated with crooked, bad, and the unlimited, which can imply sort of chaos. Aristotle contrasts these Pythagoreans with Archimedes of Croton, who was alive in the late 6th and early 5th century, who said the majority of human things come in pairs, and praises the Pythagoreans for carefully defining the pairs of opposites both in number and character. So Aristotle suggests that either these Pythagoreans were influenced by Alcmaeon, or he influenced by them. Aristotle's not sure, but this is what some Pythagoreans believe. But what it means, what this table of opposites actually means, is subject to a great deal of debate. The next slide deals with Pythagorean tuning. Now this is actually quite important, but it combines both the mystical notion of the harmony of the spheres, pardon me, and actual musical tuning. So, as I say, the Pythagoreans, and probably around the time of Pythagoras himself, if not Pythagoras himself, developed a system of tuning in which frequency relationships of all intervals are based on a ratio of 3 to 2. This interval is chosen because it is the one that's most pleasing to the ear, we have unfortunately, it's mainly medieval texts that attribute this discovery to Pythagoras, but its use has actually been documented long before in Babylonian texts. So again, did Pythagoras come up with this? It seems to have borrowed it or developed it from the Babylonians. The oldest way of tuning is a 12-note chromatic scale, and Pythagorean tuning is based on a stack of intervals, as I say, each tuned in a ratio of 3 to 2. I'm not going to go through all of this. You can look in the notes yourselves, and some of you may be more musically inclined than others and will find this interesting, but the Pythagorean musical system, and there are a number of divisions of the musical canon using Pythagorean mathematics, all of which we still use today, and all of the ones that we've developed since have come out of them. But it's quite a significant step forward in science, in the science of musicology, to have a scientific way of dividing up music. But again, the Pythagoreans appear to have attributed mystical qualities to these things. And in the case of Empedocles, as well, we have color theory corresponding somewhat to the musical theory as well, and color symbolism. So you can look at that in your own time. If you run the slideshow, there's a media file which you can look at too, which discusses in particular Plato and how he used, apparently, well, this is a discovery made relatively recently by a colleague of mine at Manchester University, looking at different sources on the history of science, but also at other sources on Plato. And what he's discovered, which I believe to be true, I believe it's been verified now, is that Plato used Pythagorean mathematics, and specifically the Pythagorean musical scale, or the 12-note division of the musical canon, to construct his dialogues. So this entailed numbering the lines, counting the numbers of lines, and it's a very strange thing for us to think about. But what it seems to mean is that in Pythagorean tuning, some notes are more harmonious and some are less harmonious. And in the 12-note scale, there's at least one note that's utterly disharmonious, and that note's usually not played. Plato used all the notes in composing his dialogues, and he placed ideas that he found favorable on the more harmonious notes, and he placed ideas like things that he found that he didn't like, that he disagreed with, like Heraclitus, for example, on the disharmonious notes. And in order to see this, you have to essentially take the original text of Plato in Greek. It can be done, it's been done with a computer nowadays, but you count all the lines and you divide it into 12 parts, and at each of those division points you've got a note. And interestingly enough, it does actually explain why Plato, or how Plato, organized his dialogue. And for many centuries, people, said, why did he write them this way? The structure is very strange. Why did he put this point here or that point there? Well, this actually explains it, and it's the best explanation that I've seen. Not only that, there are sources in antiquity who say that he did this. The reason that we forgot about it seems to be partly to do with the Romans and the invention of the codex, the book form. So Plato's texts, like all ancient Greek texts, were originally written on scrolls, and later they would be copied into books, which is what the Romans invented. A very handy way of packaging a text. But it meant that the numbering of the lines became less apparent, and then of course translations into other language obscured even further. So if this is true, and I believe it is. My interpretation is that it is. It's further evidence, I think, that Plato was absolutely a Pythagorean at a time when perhaps it was unpopular. And so this leads us to the next topic of the Pythagorean society. I alluded to them back at the beginning, these various groups of individuals, mainly in Italy, and the sort of communal lifestyle they practiced. Well, they got into trouble a number of times. So we're told Pythagoras came from Samos, the island of Samos, but that's absolutely uncertain. He may have lived there at one point. His teacher was a man named one of his teachers was a man named Pherecydes of Skyros, another island, but he's also said to have been taught by the priestess of Apollo at Delphi. At any rate, he moved to Crotona. This is the Greek city-state in southern Italy, around 530. Developed a brotherhood of disciples. Brotherhood and sisterhood, as it turns out, women were allowed in as well. They were devoted to the reformation of political, moral, and social life, we're told. The order was influential in the region. They appear to have tried to induct into their membership, at least at the lower level, not necessarily at the higher level, you had to live in the commune. At the lower level, maybe not necessarily, depends. To induct people of high standing into it. But they got into some trouble in Crotona, involved in local politics, which some people tried to suppress the brotherhood. So he then fled to Metapontum, a Greek city in southern Italy, and is alleged to have died there around 500 BC. Like I say, because none of his writings have survived, although Diogenes Laertius tells us that some existed, we have to try and it's difficult to distinguish his teachings, Pythagoras' teachings, from those of his disciples. Among the basic tenets of Pythagorean belief is that reality at its deepest level is mathematical in nature, all is number, that philosophy can be used for spiritual purification, that the soul can rise to union with the divine and escape the cycle of reincarnation, and that certain symbols have mystical significance. Pythagoras is generally credited with the theory of functional significance of numbers in the objective world of music. His followers were credited with the development of Pythagorean theorem in geometry and the application of number relationships to music theory, acoustics, and astronomy. I mean, we can see an example of this in what are called the Platonic solids. These are derived by Plato, developed by Plato, and then further developed by the Academy, used by Euclid in his Elements of Geometry. They come from the Platonic solids, as they're called, come from Pythagorean mathematics and are geometric ways of proving the quadratic equation, which again is quite an essential mathematical development. As an active organized brotherhood, the Pythagorean order was suppressed, and it seems to have gone through a period of considerable suppression, with certain Pythagoreans becoming more prominent or being tolerated in different places. So there's Archytas of Taras. This was a friend of Plato's and who helped Plato when he was trapped in Sicily by the king of Syracuse. Archytas is considered the father of mechanical engineering. He developed something called the pigeon, which was the first rocket, a steam-powered rocket, we're told. So you've got Pythagoreans like Archytas making scientific marvels at a time when no one else is coming up with anything like this. There's an anecdote that says some Romans witnessed Archytas testing his early Romans, back when Rome was a city-state, much smaller, witnessed Archytas testing his pigeon, his rocket, and wanted to buy it from him. But he refused to give it to them and even destroyed the plans for it because he was afraid they would use it as a weapon. Concerning the fate of Pythagoras himself, the accounts varied. Some say that he perished in a temple with his disciples, others that he fled to Tarentum, and that being driven from there he escaped to Metapontum and there starved himself to death. There are multiple accounts of how he died, and that should trouble historians because a person can only die one way, but it goes to show what a controversial figure he is. In the 5th and 4th centuries, there would be Pythagorean communities in places like Athens, Thebes, and the Kingdom of Macedon. They appear to have been interested in these places at the height of their prominence, and we're told Pythagoras himself actually went to Sparta during sort of their heyday, or just after it, and studied them too. So not sure what the interest in politics is about, but it's interesting. At its deepest level, Pythagoreanism seems to believe, again, reality is mathematical, and that members of the order should observe strict loyalty and secrecy. They used lots of symbols and secret handshakes and signs to identify each other. Pythagoras' religious and scientific views were inseparably interconnected. Religiously, Pythagoreanism believed in metempsychosis, that is the transmigration of the soul or reincarnation through different bodies, which can include vegetables as well as animals, as I mentioned. Heraclides Ponticus, a later writer, reports the story that Pythagoras claimed that he had lived 4 lives, that he could remember the detail of these lives. Pardon me, and that according to Xenophanes, Pythagoras heard the cry of a dead friend in the bark of a dog. Anyway, that may have been as a joke. That's in Diogenes Laertius. As I say, women were given an equal opportunity in the Pythagorean organization, and this may be the origin of Plato's notion of more or less equality between men and women. They were held to be different from men, but not in bad ways, sometimes in quite good ways. The priestess, philosopher, and mathematician Themistoclea, this priestess of Apollo, was regarded as one of Pythagoras' teachers. We're told that his daughter and his wife and others were female disciples, members of this society. Pythagoras is said to have preached that men and women ought not to have sex during the summer, holding that winter was the appropriate time. There are a lot of weird little things attributed to the Pythagoreans, and one wonders how true they are. We'll talk about those in the seminar. The Pythagoreans were well known in antiquity for their vegetarianism. Later on, in more modern times, the Pythagorean diet would be used in like our own 18th century and 19th century to refer to a vegetarian diet. One thing we're told that was utterly forbidden to Pythagoreans was the consumption of beans. Why was this the case? Aristotle struggles with this to try and explain it. One explanation is that the beans look like genitalia. Another is that they resemble embryos or something along those lines. Probably the most rational explanation that I've come across says that because Pythagoreans practiced something called incubation, and this entailed going into like a cave or preferably an underground environment, lying down and entering into a trance-like state, they would send their souls wandering throughout the cosmos. Eating beans might, due to creating stomach problems, prevent them from doing this effectively. I don't know, and that none of that may be true, but this is what this is what we're told. The story is that one version of Pythagoras' death says that he was killed by enemies when he refused to run through a bean field, which again may or may not be true. Like I say, they were supposed not to swear oaths, although we have examples of Pythagoras or others stating that there are Pythagorean oaths. But there's a quote from that in particular seems to correspond with Christian beliefs. So Diogenes Laertius tells us in his biography of Pythagoras, he also forbade them to swear by the gods, saying that every man ought to exercise himself as to be worthy of belief without an oath. As I mentioned earlier, there's probably no other source for Jesus and James' admonition to avoid oaths other than the Pythagorean connection. In chapter 5, verse 12 of the book of James, he states, "Above all things, my brothers, do not use oaths, whether by heaven or by earth or by anything else. When you say yes or no, let it be plain yes or no, for fear that you expose yourselves to judgment. This would be something that Christianity didn't always do more than offer lip service to, but as I say, the Lollards and the Cathars as well, another rather fringe group of Christians who practice mysticism, seem to have believed in something similar. Yeah, and so there are theories that Christianity, early Christianity, may have been influenced by Pythagoreanism. It's also possible that early Christianity was influenced by certain Egyptian beliefs, particularly the cult of Isis. And it may be that it wasn't necessarily that Pythagoreanism influenced Christianity, but Pythagoreanism itself was influenced by the cult of Isis, and so both stem from the same source. We simply don't know the answer to that. But this is the problem. And as interesting as this is, I'm all of this that I'm telling you, apart from the scientific stuff that we can absolutely be certain about, take with a grain of salt. Everything from the harmony of the spheres to the central Earth, the anticathon, and this oath swearing, and all these other bizarre anecdotes. I mean, some of the anecdotes say Pythagoras had a thigh made out of gold, that he heard voices as he walked over flowing water, that he could speak to animals, all sorts of bizarre things. Take it with a grain of salt. Some of it may be true, I don't know. We can talk more about this in the seminar, but it presents a very interesting problem for the historian, where we have multiple sources. And we've got Diogenes Laertius. He's using some of these different sources. I'll talk about them. And the Neo-Pythagoreans in particular, Plotinus, Porphyry, and Iamblichus, they get a bad reputation for being essentially mystics, and for their opposition to Christianity. Again, how representative are they of Pythagorean beliefs? We don't know. But we shall discuss these things in more detail later. Thank you very much for your attention.